So I'll go back over what I had already said. So right now we've got the parallax ping sensor, which is giving us our obstacle avoidance. It's on a fixed forward location, which right now does not work as well as I'd like, because it can only tell if there's someone in front of it. Therefore, it can't determine whether or not it should go left or right. It can only determine that there's something in front and it needs to move. So right now it automatically turns to the right at a speed of 55 out of 255 whenever it senses something in front of it. There's a webcam which will end up being used for live point of view driving of the thing, so I can use the ingenious 2-mile wireless link up to 2 miles and just drive this somewhere. Eventually we're either going to put the ping sensor on a swivel, on a 180 degree swivel mount, so we could actually, if it detects something in front of it, it turns and determines if there's something there or not. The location might also need to be changed from there if we end up doing a full 180 degrees, otherwise it's going to hit these every time it turns with the range. I've got the Arduino Mega with its 52 inputs and outputs for plugging all the sensors in. The Arduino Mega is also being used to control the motors. If you see the ribbon cable coming out of the Arduino Mega,
I do.
Alright, that goes into the motor controller that was originally in the Ranger 2 Storm Series wheelchair created by Invacare, which we ended up picking up from the restore for zip.
Oh, nice.
Yep. And then this little panel box right here, it looks like it's just outlets. So you'll notice it has a couple acronyms, NO and NC. Normally open, normally closed. There's a 4-port relay board in here, which allows me to turn on and off through the computer each of these outlets. So the normally closed ones normally have power. Those are hooked up to the Arduino and to the wireless link. Normally open, which means there's no power, is hooked up to the speakers and to the light. So all I have to do is send this command saying turn on relay 1 and it'll turn on the light, turn on relay 2, it'll turn on the sound,
I see.
turn it off and it'll turn it off.
Yes.
It has, as Paul likes to call them, 2-bit Hor lights underneath the wheels. What they are is LED strips that he picked up from IKEA, and he absolutely loved those, so I ended up putting them on underneath. They're held down with Velcro. They end up going to this switch right here, hand toggle, because that's not important enough to need an actual switch.
Certainly better used at night than during the day.
Yeah. Right now I guess I could turn them off because no one can see it out here. There's a 4-port powered USB hub which is plugged into the Raspberry Pi. The Raspberry Pi, the 4-port hub is plugged into the Arduino Mega and to the keyboard. It also plugs into the relay control board and the camera, the webcam, which will give us the microphone, the video, the ability to turn on and off the power, and the ability to control the movement of the machine. The Arduino is coming out to, or the Raspberry Pi's video is coming out to a 3-inch backup camera that I picked up on Amazon for $30, and that's being powered by the APC UPS at the bottom. So this thing has 2 wheelchair batteries which are giving out 120 volt AC power through the inverter of the UPS. So that gives us the power for all these nifty gadgets that we've got on here. Currently it is controlled by the keyboard on it, but I've also got an Arduino Explorer downstairs which has been programmed to send out the same commands that are needed to actually control this. So instead of using the keyboard, I could plug the Explorer in and control it that way. The object avoidance, come back. It's on. It's plugged in.
Now they freeze up.
Yeah. Actually, the Arduino got unplugged somehow, so let's actually unplug it and plug it back in.
This is that blue wire?
No, the blue wire is the network. This black wire is the sound, video. That's the one that goes to the 4-port hut. And now we have our
Nice.
and now we've got it back. So, if we want to, we can turn on object avoidance.
Alright, free range robot.
Not really. I would never give this free range at the moment. It is not ready for that. But you'll notice, when you hit E the first time, it says avoidance on.
Alright.
Alright? If I turn it on, stand in front of it, would you?
Yep. Very
I like it. I like it.
And it moved.
I felt safe.
And unfortunately, something is going on. Why are you disconnecting so often?
Oh, I see you got these sonic things.
Yep, ultrasonic rangefinder.
Mm-hmm. Is that
And
what
you'll
stopped
notice-
it?
By putting my hand in front of the rangefinder, it determines that there's something in the way.
Aha! Yeah, you have to have one of them.
And what I'm thinking is one of the changes of the code that I might do is depending on how close something is that's in the way, is how fast it'll turn. So the closer it is, the faster it turns out of the way. So if a kid decides to run right in front of it,
Yeah, 'cause you
it
know
stops,
it will.
it turns real quick. You know? So that's one idea. One of the other things that I need to change is you'll notice that, let's turn off object avoidance for the time being, is you'll notice when I got that turning, alright, one wheel is going forward, the other wheel is going back.
Oh yes.
Alright? What I'd like to do eventually is, instead of having it turn in that manner, I would like to have it turn so that if I wanted to go gradually to the left, it slightly increases the power on one side or slightly decreases the power on the other, or both. That way it does a gradual turn rather than having to stop it and then turn it. Because at the moment, to be able to do turns, I have to hit, turn. It actually stops the machine, then turns it, and it means that I can only do right turns.
Sure.
On the dime turns rather than, a gradual swerving turn. Which really sucks when you're going up a curve. Because you go up, like if I was doing that in a car, I'd cross over into the left lane, I'd be like, shit, I have to turn left.
Right.
You'd turn left, give it some gas, then you'd have to turn right, give it some gas, turn left, get back in your lane, go forward until you have to turn right.
Right.
And it just gives you a choppy. And if I can give it the ability to do the gradual swerve, it increases the efficiency of the machine in total.
Nice. Yeah.
So, one of the other nice things is, because I have this being controlled via the Raspberry Pi, I have the 802.11 link here that gives me the 2-mile range. 2-mile range,
Wow.
alright, through a Wi-Fi connection.
Oh wow. That's
It's
a
a
long way.
2-mile Wi-Fi link, alright? And what I can do is I SSH into the Raspberry Pi, and what I can do is I can stream the raw video coming out of the camera with FF Server, which is the server application of FFmpeg basically. And then that allows me to see what the robot sees. I SSH into it instead of using the keyboard that's on it, and I now can do up, down, left, right from there. One of the nice things about doing it that way is, at this point, I have yet to have any of the glitchy errors that I have with actually using the keyboard by doing it through
Interesting.
SSH. So because I'm SSHing into it, I'm actually getting a lot, it's a lot more effective. It's a lot more efficient to do it that way. So, one of the other things you'll notice.
So that could maybe be related to your power issue, like you were.
Yeah, I
sure
think
how much you're getting.
I don't
So is
know
the keyboard
exactly.
getting enough juice to send the signals that it needs.
The problem with these keyboards also is the fact that these keyboards are not just keyboards. They're also USB hubs. So I've got a powered USB hub going to another USB hub, which is drawing more power for those other ports. Granted, it's not drawing a lot more power, but if I plugged anything in there, I'm afraid that I'm going to lose pretty much all ability to use the keyboard. It's not the first time I've had this happen with the Raspberry Pi. This one and the one I've been using for my media server have both been having this issue. Right now we're working on cross-compiling FFmpeg for the Raspberry Pi. So then we'll transfer over the dev file that we create with check install, and we just do a dpackage-i and it installs it. No compiling on the Raspberry Pi needed. And I've also...
I heard it.
Okay. Well, it's a bit technical, but...
That's okay.
So here's another interesting thing. Have you ever heard of ROS?
Yes.
Alright, do you know what it is?
I don't remember
Alright.
anything.
ROS is the robotic operating system.
Oh, okay.
It's a collection of software utilities for building a robotic controller system, basically, a controlling system for your robot. What I've done is I've installed ROS on the Raspberry Pi, and it allows you to communicate with various sensor inputs, control things through various methods. It also has its own packetized serial communication protocol. So by running or putting software on the Arduino that then talks to the ROS on the computer, I'm hoping to be able to increase the robustness of the network and decrease the amount of delay time.
Sure.
As well as, not that delay time has become a big thing yet, but at some point it would.
Right.
As well as make it so that the messages I know are coming through clean. I know exactly the sensor input. Right now, the ping sensor is sending, it's doing all of its controls on the Arduino, not on the computer. Which, at this point in the game, it's making it more stable to do it that way than it is to do it on the Raspberry Pi itself. I'm offloading as much of the processing needed to do this to the Arduino, because I know the Arduino is just going to pop through the code and keep popping through the code and not stop doing it. The Raspberry Pi is all dependent on what else you have going on. And once I've got, I don't know how badly my control is going to be after I get FF server running. It might be that I end up needing to do something different like motion. It's a webcam security camera software. What it does is it takes a set interval. It'll take a snapshot, and it'll save that image to a folder.
Sure.
So what I could do is I could have it set up to take a snapshot, save the image to a folder in Apache, a web server, and then just have it keep overwriting that same file.
Sure.
And then I just have a script that refreshes the page over and over and over again, the web page, allowing me to see what's going on. Yeah.
It's a robot, right?
It's a robot.
Okay.
Show me how it works. That's awesome.
Can I ask, a question? And I'm sure that you did it the way you did it for a reason. Just as a layman's question, sitting there looking at it, why didn't you use a small tablet laptop to do this?
I actually originally had a laptop on there.
Yeah.
The main reason is because hit Q. Alright, that stops it. Hit S. Alright, hit O a couple times. Alright, now it's backing up. Hit O one more time. Not 0. O. Alright, now hit S. Oh, you already hit S. Hit A.
Yeah, cool.
You hit O a time or two. There you go.
Cool.
Alright, you want to see even the cooler thing?
It can talk.
Ed, I need you for a demonstration. Alright?
Right. Stand right where you are.
Can you stand,
Let's have your watch.
go to the other white line directly in
And it
front
can
of
take
you.
pictures.
Oh, hold on. Let me make sure that object avoidance is on. Do you see a green light?
No.
Okay, thank you. Now do you see a green light? Okay.
Well, that's the brakes, right?
Sort of.
Why you always on my screen? Cause I'm Boy Scouts.
Here's Boy Scout. Goes here.
That's awesome.
It's all yet.
Now, is that some kind of connect?
And no doubt it avoided me for general purposes.
Yeah, so it stays alive.
Very interesting.
Hit Q.
What's that, a giant inverter on it?
It's a UPS.
Uh-huh.
Alright, now if you hit W, it goes forward. Kind of like a game.
That's cool.
You know, WASD controls on the game. So
I
Ed,
bet I could drive it back right there.
It'll be plowing snow before long.
you know what that is?
Yeah,
It's a 2-mile range. It's an Ngenius 2-mile range Wi-Fi module. Ah, hit E. Thank you. Now hit T. Nice catch, by the way. It's dancing. Thank you. Just once. It'll take a couple times for it to stop dancing.
You can put a robotic arm on it,
Eventually.
right? So if you
How
want
much
to
does this
go
cost?
somebody wants to give you a cup of coffee,
$170 for the batteries.
coffee and then bring it back tomorrow night.
That's it?
You can
Pretty much.
send
Just
it down
batteries?
to the local
Pretty much. The rest of the stuff we basically had sitting around the house.
on the camera.
You're getting good at that. Now hit L to slow it down, by the way. You see how that works? You got the O right above the L, so it's like an up and down arrow. I just didn't want to set it. Yeah. O is faster, L is slower, because they're right above and below each other. And then WASD is on the other side. T does the dance.
Oh yes, right.
T is for test.
Dancing.
Watch that tray hit you in the thigh there. It's gonna hurt.
Oh, now you live there? Now I can really stalk you.
But for now, that should be good.